This is section 5.6, exponential and logarithmic equations. We're going to look at solving these, and the goals are basically simple. As we have an exponential equation, in other words, when the variable is in the exponent, our goal is to first get the base on one side of the equation by itself. Remember that the variable being the exponent means there's a number for the base. We want to get that on the one side of the equation to the left or the right by itself. And when you have a logarithmic equation, in other words, the variable's inside the log or the base of the log, you want to get the log on one side by the equation by itself. In other words, isolate the log. Let's look at an example. 4 times 1.5 to the x plus 3 equals 15. This is clearly an exponential equation because the x is in the exponent and the 1.5 is the base, so I want to get the 1.5 by itself. So I'm going to start by subtracting 3 from both sides. You get 4 times 1.5 to the x equals 12. I'm going to get rid of this 4 now because it's not part of the base. So I get 1.5 to the x power equals 3. Now we can do a couple things here. I personally like changing the forms. You're welcome to hit both sides with a common log if you want to. Either way will work. This is, my base is 1.5, my exponent's x, so x equals log base 1.5 of 3. I do my change of base formula, I get x equals log base 10 of 3, divide by log base 10 of 1.5, which is 2.7095. And what's nice about this is we can plug this back in and check our work as well. Another example is log base 3 of 1 minus x equals 4. Now again, I have the log already by itself on the left-hand side. My base is 3, so I'm going to just change to the equivalent exponential equation. Base is 3, exponent's 4, so 1 minus x equals 3 to the 4th power. 3 to the 4th power is 81, so 1 minus x is 81. And if you do the math, you get x is negative 80. Here's another example. 250 natural log of x plus 4 plus 1250 equals 1800. Again, the x is inside the log, so this is a logarithmic equation. I want to get the log by itself, so I'm going to subtract 1250 from both sides. You get 250 natural log of x plus 4 is 550. Divide both sides by 250, you get natural log of x plus 4 is 2.2. Again, I want to change the equivalent exponential equation. The base is e, the exponent is 2.2. So you get x plus 4 equals e to the 2.2. So x is negative 4 plus e to the 2.2, which is approximately 5.025. Now we occasionally get a situation that's really ugly where we get multiple bases. We have e to the x plus 3 equals 4 to the 3x power. In this case we have two different bases. So we're going to choose to deal with the base e first just because we have base e on our calculator. It may wind up being a little bit easier to work with. So I get hit both sides with the natural log. I get natural log of e to the x plus 3 equals natural log of 4 to the 3x. Now we can do one of a couple things. We can reduce this left-hand side immediately, or we can just apply our exponent rule, which says you can bring your exponent out front, so it becomes x plus 3 times natural log of e. This 3x comes out front, you get 3x times natural log of 4. We should recognize that natural log of e is just 1 because the bases are the same, it's just 1. So you get x plus 3 equals 3x times natural log of 4. Believe it or not, this is just a linear equation. And your rules for linear equations, you get your variables to one side and your constants to the other. So you get x minus 3 natural log of e times x equals negative 3. We're going to factor out an x on the left-hand side. You get x times 1 minus 3 natural log of 3 is negative 3. Divide both sides by 1 minus 3 natural log of 3. And you get a solution of x is approximately equal to 1.307.